Hello guys, today we are going to discuss clippers. Clippers are the network that are used to clip some portion of input waveform without distorting the applied voltage. So let's suppose we got a waveform of 20 volt and we are going to clip this 5 volt from this input waveform. We use clipper, we use a clipper, so it will clip this 5 volt voltage from input voltage and we got 15 volt of output voltage. So to put this network to give us an output voltage of 15 volt, what we are going to do, we put V 5 volt, input voltage of 20 volt. So what this network will do, it actually clip this waveform and convert into a waveform of amplitude 15 volt. Now let's see the simulation of a clipper. Now what happened to this network? So we put this network in this simulation software. So 5 volt is added here. So what happened, actually 5 volt is clipped from this network. We discuss in the lecture in ideal case, and this is a realistic case. So we got a value of 14.2 volt. So this is the simulation. For example, what we are going to do, if we change this value to 8 volt, what happened to the waveform? So the waveform here we got 11.2 volt. So 8 volt is clipped with a potential barrier of 0.7 volt and other voltage drops. So we got a value of 11.2. So we discussed a series based clipper. Let's move to a parallel based clipper. Now this is a parallel clipper. So what they are going to do with this type of waveform? See here, when we look into the circuit, we are checking output from here. So when the diode is on, what happened? When the diode is on, we got this type of circuit. We got this type of circuit. Now, so from this network, one thing is clear. One thing is clear, that when the waveform, when the input signal is at 0, we are receiving a constant DC voltage of 4 volt. So 4 volt is actually fixed for input voltage of 0 volt. Now what happened when the diode is off? What happened when the diode is off? When the diode is up, we got an output voltage of what? Output voltage is actually equal to input voltage. So for the on stage of diode, we are getting constant 4 volt voltage. For the up portion, what we are going to get, we are get in 16 volt of total of 16 volt voltage. So the output waveform will look like this. And 4 volt is constant for both the swings, for positive and negative swing. So when the diode is on stage, we are getting only a constant voltage of 4 volt. So let's see the simulation of this circuit. Now let's see to the pulse. So we are taking a constant voltage 4 volt here and a complete pulse of 16 volt. So this is a complete pulse of 16 volt. So let's change this value to 6 volt. What happened? So the constant value here is increased to 6 volt. So for the negative pulse we are taking a constant of 6 volt, and for the positive pulse we are taking a complete 16 volt. Now as we see in a simulation, if we increase the value 4 volt, so the constant value when the voltage is when the input voltage is at a zero condition, so is increases with for example, if we increase a 4 volt to 6 volt, so that value, that constant value is increases to 6 volt. Now next topic is a clamper. So clamper is a combination of resistor, a diode and a capacitor. So clamper is actually used to modify the input waveform to next level of DC level. So let's suppose what this clamper will do. So for example, this is input voltage and we convert this input voltage to this DC level, but the swing, the complete swing actually remain the same. For example, we have a swing of 30 volt, so for the output signal the swing remain 30 volt. So let's start. So for example, when the input voltage is at minus 20, what happened to the circuit? So what happened to the circuit? For example, when the network is getting this type of signal, so for the negative swing, what happened? For the negative swing, the diode is on. The diode is on. When the diode is on, so this capacitor will start charging. For the negative swing. So the negative swing have amplitude of minus 20 volt. So the capacitor value will charged to the capacitor value will charge to 25 volt. For the negative swing, when the diode is on, what happen when the diode is off? When the diode is off state, what happen? So we are taking an input voltage of 10 volt and the capacitor is charged, which is 25 volt, and output voltage is actually equal to 35 volt. So actually we are taking an output from the resistor. When the diode is up, no current flow through here this branch, so an output voltage will equal to 25 volt. So if we look into the waveform, so we got an output voltage of 35 volt. So let's see the simulation of a clamper. Now if we look into the waveform of this network, so here in input voltage of minus 20 to plus 10, so this is in input voltage, and we are getting an output voltage of a constant value 4.19. so it include the voltage drop across the diode and other potential drop, and output voltage maximum output voltage of 34.3. so we actually discuss it in our lecture that it was a 15 volt. So we discuss in our lecture the ideal case. Here is the realistic case. So this is the waveform. So this is the end of our lecture. Thank you for watching.